In this demonstration, we'll explore the integration of Denso Robotics into Rockwell Automation's Emulate3D software for the purpose of integration prototyping, demonstration and simulation, and virtual commissioning of Denso robots with Logix control. A library of Denso robots will be presented from within the Emulate3D application, just like the other material handling automation components. To install a robot, simply drag the selected robot from the catalog into the Emulate3D model space and position as needed. Next, we'll need to select an appropriate tool flange that will be used for mounting the end-of-arm tool to the robot. The tool flange is added to the hierarchy of the last joint of the robot. The tool flange has a connector feature that allows for quick connecting of different end-of-arm tools. Next, we'll get an end-of-arm tool from a catalog and drag it near the tool flange. When we get the tool close enough to the flange, it will automatically snap into place because of the connector feature. Any custom end-of-arm tooling can be used and may be added to custom catalogs for future applications. With the mechanical elements installed, it's time to connect the Emulate3D Robot Framework Controller and run the model to see if we've installed everything correctly. Watch as the robot moves to position the tool center point to the home teach point. In the Emulate3D environment, we can control the Denso robot movements with a variety of methods. In this demonstration, we'll use visual teach points. The Robot Framework Controller provides an interface for adding and naming new points as we command the robot to different positions. Here we'll teach 4 new points as pick, pick pounce, place, and place pounce. The Robot Framework Controller has a quick script drag-and-drop programming interface where we can build the sequence of operations. Here we'll use move commands and recall the different points that we've taught the robot. The teach points are 3D visuals with their own location and orientation properties. When we command the robot to move to a teach point, the move command extracts both the location and orientation from the given teach point. The open gripper and close gripper commands are subroutines within this robot program, which command the mechanics of the given tool and can be called as needed. With our pick and place sequence programmed, we can now run the model to watch the robot perform the actions. The program executes the sequence from top to bottom, suspending at each command line while the command completes. Note, where needed, the programming interface does support parallel operations. Through Rockwell Automation's integrated robot solution with Denso Robotics, the robots can be directly controlled with Studio 5000 programming and integrated motion on kinetics drives. The digital machinery in Emulate3D can be driven by both simulation logic from within the model and by connected PLC controls. The Emulate3D model contains Denso's physical description of the robot, and the Logix controller contains the logical description of the robot. We connect these two truths together for virtual commissioning of the whole integrated solution. In this system, containers are conveyed to the robot. The containers are registered to the PLC controls by a signal from this virtual sensor, and are position tracked until the robot picks them. The Logix program solves the forward kinematics of the robot geometry to satisfy the target positions and runs the motor drives to execute the motion of the robot. This concludes our demonstration. Thanks for watching.